So here we are finally, again, I'm getting an opportunity to get back to this gear project. I've actually been kind of busy. I haven't been able to get past where I was the last video and last post. Anyway, so I've got the gear cut, and as far as making it functional, there's only two other things I need to do. One, probably the most important thing, is getting the double broach done. Now, I played with the idea of coming up with some kind of special holder. Like, screw it, I'm not going to bother with that. But there was an order of operations here which I was fighting with. I don't know if you can notice, but this is a 3/4 inch hole, and this is a 5/8 hole. And I used the 5/8 because I had my little mini pallet here, and I've got it drilled and tapped for these shoulder bolts that I've got a rather big supply of. And I use this to, originally I did it for that bearing block that I made, and I transferred the same premise over to here, so this fits it nice and tight. Yeah, one hand, I can't really pull it off. So, there we go. So it fits in nice and tight. It's not like a press fit by any means, but it's good enough. And I screw that in there, and I do all my operations. It's just a nice way to fasten it down. So what I've been fighting with is what step to do next. Now I need to take some meat off each side of this sprocket, right? Because this is bigger or smaller. So this is a 3/8, and that's 1/2 inch. And for alignment purposes, there's multiple gears being stacked up. I think I need to take this down, so I might as well make them all the same. But the screwy part is the center half of this gear. That's 1/2 inch. So the center's raised. Now, and I've been fighting with myself the best way to go about doing this, because it's just so convenient to be able to plop that on there and zero everything out. Like I throw that in the rotary table, and I just drop a countersink, a 2-flute countersink in there, and I center that, and I plop that in there, and everything's just centered. It's nice and convenient, and I didn't want to lose that, but I need to make the hole bigger for my broach setter. So I was fighting what to do first. Do I maintain that, do all my other work, and do that last, and then when I'm doing my broach, I don't have a lot of meat. So I fought with it, and I fought with it, and I fought with it. Screw it. What I'm going to do, and bear in mind that I'm trying not to use a lathe when I make this gear, because I'm working under the premise that my lathe is busted. That's why I need to make the gear. So what I've decided to do is I'm going to make this hole 3/4 of an inch, and I'm going to do my broach. I'm going to do my double broach, and then I'm going to move on. I'm going to do everything else. I just like the security of being able to put that in my press. Everything's the same size. Everything's going to stay nice and secure, nice and square, and I can do my double broach, and then I can move on from there. That's probably the most critical part. I need this bore and the broaches, everything squared up to the face of these gears. So, well, actually, this part of this gear. But anyway, so I'm going to do that first, and then to get back to here, because this is where I'm going to do all my milling to bring it down. I'm going to prop this up just a little bit and mill everything down to match the profile. What I'm going to do is I'm going to take little oil-light bushing, and so this is 3/4 inch OD, 5/8 ID. So what ends up happening is that after I make this hole bigger, and another thing you need to keep in mind is I haven't really paid too much attention to this and this, or more importantly that. So I'm going to put this in the mill. I'm going to center everything based on this. I'm going to square it all up based on this, and then I'm going to enlarge that hole to 3/4 inch, so I can do my broaching. And then when I go back and I need to use my bolt again to secure it to my mini pallet, I'm going to take this oil-light bushing, and I'm going to push it in there. Well, it's not going to push, it's going to slip in. And then this goes in there. Ta-da! So to give you a nice, there's a burr on this somewhere. So this goes to here. Well, imagine that's what the gear I'm making is going to have this hole. This goes, trust me, it fits. Something like that. Right, a snug fit. And then this is going to go like that. Right? So same application, I'm going to have that same size hole. I'm going to have those two broaches done. Then this blank, and I'm going to use that oil-light bushing, and then I'm going to get back to my bolt. I'm going to fasten it down to here, and I'm going to finish my steps. I'm going to flip it over, and then I'm going to have to, it's going to be sitting on a raised portion right here in the center. This side actually is going to be floating because I'm going to be taking whatever the measurement is off of there, so 3/8. I'm going to take a 16th off of this side, 16th off of that side. So after I do that, flip it over, repeat, Bob's your uncle, and I'm done. So hopefully, let's see how energetic I get tonight. Maybe I can actually get most of this done. So the first step is to get this back in the mill, center everything up. Alright, so here's the setup. It's a long time coming. I've been farting with this for well over an hour now. So I followed my usual process. I centered the rotary table to the quill. I know that's good. I then drop my mini pellet on there. I rig it up quick with the counter bore, and I countersinks her, and I center that to this, and then I hold it in place, and then I clamp it down. Its position really doesn't matter all that much, but it gets me close, makes things a little bit easier. And then what I did was I actually started off with the bolt. Started off the bolt, and I had it in there, and I was running the indicator off the quill, and I was reading the edge, the top of the key, top of the spurs. And I was fighting with it. You might be able to notice, I got quick little marks here, 90-degree marks, just so I could center. And I was fighting with it, and I just couldn't get it. And I resigned to the fact that my hole was so off-center in relation to the top of my teeth that I just couldn't get it with this anymore. I was butting up against the shoulder, and it wouldn't allow me to move it anymore. So I left that in place. And I took some 1/4-20s, and I don't have it rigged right. I mean, I should have something underneath. It should be something a little better, but these are got it bound down pretty tight. And then what I ended up doing is I tried running it off the quill, and I was fighting with it, and it wasn't a very sturdy setup. So what it is, I changed it up a little bit. Now I know the rotary table's centered to the quill. I don't have to worry about that. And what I needed to make sure is that this was running concentric with the table, and I wanted to make sure I had whatever I do here is going to run concentric with the outside of my gear. So I know this is going to run good. My logic is that if my gear is off at all in relation to my table, it should walk. It should get wonky. I forget the damn term for it, but anyways, I'm sure that you guys know what I'm talking about. Anyways, this is going to act wonky, so I decided to firm up my setup a little bit, and I'm going off the bed of the table now, and I'm reading the top of the teeth, and I got it at 0, 0, and I ran around, and I'm within 1/1000. So the reason I'm making this video is I know this is good in relation to this, and I know this is good in relation to that. My hole is, whatever the hell that damn word is, it's off by 30,000. Whichever direction, I'm not too sure. It's off by 30. And, you take 30 and you dial it in on your vernier, look at the gap. It's not a lot, but regardless, the whole reason I did this is I knew this hole was going to be off. I didn't know how badly it was going to be off, but it's off 30,000. So now I've got this all dialed in, and I'm within 1,000, regardless of where I go. And considering the way that I milled this, I'm fine with that. So now I've got myself a 1/2-inch end mill, and what I'm going to do is I'm going to drop this down in here, and I'm going to zero it against my mini pellet, and I'm going to use that. I'm going to adjust my whatever axis that is. I'm sorry, I'm tired. It's midnight shift. I'm going to adjust this, and I'm going to slowly work this out to be exactly 3/4. I do have a boring head, but it's unreliable, and it's a pain in the ass, and when you start getting the smaller diameter holes, it's more pain than it's worth. This way I can drop this 1/2-inch end mill. It's going to slip right in here. I'm going to have no problems whatsoever, and I can dial this in, work it, dial it, work it. And obviously I don't have this fastened too bad, or too much, so I can't go too crazy. I'm not going to do it one pass. It's going to give me an opportunity to make a nice clean hole. I can measure it on the fly, everything be right as rain, and it's going to be perfect to the outside of my gear, which is the whole point. So like every process, machining process, 90% of it's set up, 10% is actually get the work done. I'm happy where I am now. All right, quick little demonstration on the difficulties of doing some of this stuff on a mill. Sorry about the glare. Anyway, big clunky calculator brought to you by not owning a camera. I do everything with my phone, including all my calculations, so I needed to grab this from the line. So what needs to happen is that hole right there is a measured 6251, and I get to do that with my little handy dandy little inside ID mic. So I'm very comfortable with that number. Now what I need to get to is 75.4. Again, that's this number here, and I did it with my vernier, but you know, hey, I've got this micrometer, so that's what I'm going by, and this very accurate. If I had my other hand, I'd walk through how it works. So you got a little rad there, and the trick to using this thing is to butt that little seat up. Make sure that's sitting parallel. So you butt it up there, and you spin it, and you spin it. For those who haven't used one of these things, and it's got a little clutch in there, a little slip. You keep turning it, and you give her a wiggle, and you give her a turn, you give it a wiggle, you give it a turn, and then when you get close, you think you're comfortable, you keep holding it, and you give this little binding post. It stops it from moving off your number, and you pull it out, and you read it. So anyways, let's see, glitter's killing me here. Anyway, it worked out to 75.4. Now, I'm using a 1/2 inch Endmill. 1/2 inch, okay, so I've got everything centered, right? So everything's centered, so I know the outside of the spur gear is concentric with everything related to the mill. This hole is off. In theory, the very center of this end mill is bang over the hole, the center of the hole that I want to make. Not this hole here, but the hole I want to make. That's key. So that's a 5 inch or a 1/2 inch end mill. So 0.5, right? There's my little 0.5 just to remind me. Now these are diameters. What I'm dealing in is radius. So because I'm going to move the bed, and then I'm going to rotate the rotary table and slice it off. But that's done in rad. So what I need to do is break all this down. So I got a 1/2 inch end mill that's on center. The cutting from center out is 1/4 inch, and then I got to cut this up. So that's my original number. So I got to cut that in half. So what do we got here? We got point, big clunky calculator. Divide that by 2. Bam. So that's my rad. That's the rad of the hole that I want to make. So I need to move it a fair bit. So now what I'm going to do, just for proof of concept, what I'll probably do is I'll take, so I'm at, right now, the end mill sitting at 250. I need to be sitting at that, so I've got an adjustment of 120 thou, roughly. So I'm going to go 100. I'm going to go 100 thou. And I'm going to take a pass. Maybe even go 50. Make it nice and easy. I'm not bound down all that tight. I'm going to go 50. I'm going to take a pass, and I'm going to measure it. And I'm just going to make sure I'm going the right way, and I'm going to creep up on it. You get excited and you do these things too fast, it ends up biting you in the ass. So anyways, I'm going to creep up on it. I'm going to take another number. I just want to do a quick video just to, for somebody who hasn't done this before, you might get a little rambunctious and you start applying these numbers to these numbers, and you're going to move too much and you're going to trash your part. So keep in mind, you're going to move it. It's different than a lathe. Some of the dials in the lathe, they compensate for it. So when they say you move it in by 10 thou, it only takes 10 thou off the whole diameter, right? In this case, I'm removing off the rad, and I got to bear that in mind when I'm moving everything around. So just wanted to make a quick video on that, because somebody who's trying to copy what I'm doing, if you don't realize what's going on with the math, it can bite you in the butt. So anyways, there you go.